Good morning, Ananya. Am I audible?
Yes, sir.
Yeah. So we'll just read for 5 minutes for others to join. Okay. In the meanwhile, you can revise the topics of the previous classes that we have discussed.
Okay, sir.
Good morning, guys. Am I audible?
Yes, sir.
Yes, sir.
Okay. So what was the last concept we discussed in the previous class?
Functions.
Functions.
Yeah, functions. We saw the different kinds of functions, no? 1 minute. I'm just sharing my screen. Okay, listen. So the last question that I solved in the class was this, right?
Yes, sir.
The next point that we are going to see is about modulus function, right? So if you are able to define a function from R to R defined as f of x is equal to mod of x for each element of x that belongs to R, then this can be called as a modulus function. So f of x is basically defined like this. So mod x can be split into two values like this, where you take one value to be x and the other value to be minus x. Okay. So you will take f of x is equal to x when x is greater than or equal to 0. And you will take it as minus x when x is less than 0. So basically what I'm trying to tell you here is, we know that when you have a number, when you have a real number for that matter, let's say I give you a number of 2 and I ask you what is the modulus of 2, you're going to tell me the answer as 2. Whereas what is the modulus of minus 2? That is also 2 only, because modulus always gives us a positive value. This we know, right? When this is going to be the scenario, the important question that is to be answered is, right? How did modulus of minus 2 become plus 2? So modulus of minus 2 became plus 2 because you actually did this operation of minus 2. So the answer came out to be plus 2. That is the basis on which the function is split into two values as x and minus x. So you write f of x is equal to x when the value of x that you're going to substitute within the modulus is either going to be a 0 or a positive number. Whereas you write it as minus x when the value of x that you're going to substitute within the modulus is a negative value. Right? Minus x when x is less than 0. Are you able to understand this point? So this is the basic definition of a modulus function. And when you plot it on a graph sheet, for x is equal to 0 and the positive values of x, you will get f of x is equal to x, which is a straight line passing through the origin, making an angle 45 degrees with the x-axis. Whereas when you have f of x is equal to minus x, then it is going to be a line which is passing through the origin, but not making an angle 45 degree, rather making an angle of 135 degrees with the x-axis, meaning x and minus x will be perpendicular to each other. So you will get a V-shaped graph for modulus function. This is what you need to understand. Can make a note of this. Make a note of this. Let me know once you're done.
Done, sir.
You done? Okay.
Done, sir.
Yes. So that is all about the modulus function. The next type of function that comes into picture is the signum function. So if you define a function f mapped from R to R, and you write f of x is equal to 1 when the value of x is positive, and if you write f of x is equal to 0 when x is 0, and f of x is equal to -1 when x is less than 0, then this kind of a function is what is called as a signum function. Right? If you see the domain of a signum function, it is real number, but the range of the signum function is only going to be 3 values. What are the 3 values? You will either get the output as -1, or you will get the value as 0, or you will get the value as 1. Right? So how does a signum function look like? It looks like this. So whenever in a graph, right, you're putting this kind of an open circle, means that point is not included. So to be more specific, right, it is called as point of discontinuity. It's called as point of discontinuity. Okay. So y will be equal to 1, whereas here it will be in such a way that y will be equal to -1. At x is equal to 0, y is also 0. So basically, signum function is nothing but it is the modulus of the function divided by x. Modulus of x divided by x. This is what is called as signum function. So modulus of x by x for x not equal to 0, and it is 0 for x is equal to 0. That is the meaning, no? Mod x by x when x is not equal to 0, and it is equal to 0 when x is 0. So this is going to be the signum function. So all that you need to know is, you need to know what is the domain and range of the functions. Is this clear, guys?
Yes, sir.
So make a note of this. If there is any doubt, please ask.
Excuse me, sir.
Hmm.
You said that mod of any number, any negative number is the positive number. So suppose for signum function f of -1 is there, means we'll get mod -1 as 1 divided by -1, right?
That's not how it works. F of x is equal to mod x by x means, observe, that's not how it works. You should not combine both. So f of x is equal to, see, when I write mod x divided by x, denominator is nothing you need to be worried about. So how do you write mod x when x is greater than 0? Check your notes and tell me. How do you write mod x when x is greater than 0? You write it as x only, no?
Yes.
Balaji, are you there with me?
Yeah, sir.
So first of all, everyone switch on your videos. Everybody. Yes. So Ashwin, you also. Ashwin and Santosh. So mod x is x when x is greater than 0, correct?
Yes, sir.
That's what we wrote here. Mod x is x when x is greater than 0. So you will write it as x divided by x. So what is x divided by x? It is 1.
1.
That is why you wrote 1. Okay.
Yeah, okay.
Mod x when x is less than 0. What is the value of mod x when x is less than 0? It is -x. But the denominator x is x only. So what is -x by x?
Minus.
Right. When x is equal to 0, it is 0 itself. That is how the signum function is defined.
Okay, sir. No, I got confused with that
I understood.
modulus function.
That's a valid question. It happens. So mod x is substituted before itself. You take the definition of mod x, you don't do it after you substitute the value. If at all you do it also, see, for example, I'll come to your question also. If you want to do f of minus 2. So modulus of minus 2 divided by minus 2. And I extend the minus 2. So what is modulus of minus 2? It is 2.
Yes.
And denominator is minus 2. So answer is still minus 1. Though the modulus is giving you the positive value, but the denominator is still negative.
Yeah. Okay, it still follows the rules, right?
Exactly. It still follows. That is how math works. It should work.
Understood, sir.
Yes. Are you guys clear? Is everyone clear with this? Yes. Shall I proceed?
Yes, sir.
Listen. And the last kind of function that we are going to see is called as greatest integer function. The name itself is suggesting greatest integer. Okay. See, in some of the books, they call it as step of x also. Why they call it as step of x, I'll tell you. So how is it defined is, first of all, if I have a function f that is defined from R to R. Last class, we discussed about real valued functions. You remember? Real functions and real valued functions. What are real functions? Real functions are those functions which have the domain as real numbers or subset of real numbers. What are real valued functions? Real valued functions are those functions who have the range as real numbers or subset of real numbers. Real valued means output, real means input. Okay. So here I am defining a real valued function called as greatest integer function, which is defined as f of x is equal to, you put a square bracket and write x within it, you read it as greatest integer of x. You read it as greatest integer of x, where the x value can be substituted as any real number. So when I say real number, you can substitute fractional values, you can substitute positive fractional values, negative fractional values, everything. But this, when you substitute any real number into the greatest integer of x, the output will always be an integer. That is why it is called as greatest integer function. So input will be any real number, but the output is always a integer. You're able to understand what I'm saying? So you call this f of x is equal to, you put the square bracket of x, which is called as the greatest integer function. And I told you it should be an integer. Now the next question is, how is that integer supposed to be? For example, I'll take an example, then I'll explain this. See, for example, if I put greatest integer of 1, it is 1, because 1 itself is an integer. Greatest integer of minus 1 will be minus 1, because minus 1 is also an integer. But the challenge starts when I have a decimal value. If suppose I ask you, what is the greatest integer of 1.2? 1.2 is a real number, but it's not an integer. But input can be a real number, but what should the output for according to this definition? It should be an integer. So what is the greatest integer of 1.2 is, can I write this 1.2 as 1 plus 0.2?
Yes.
Where 1 is the integer part, 1 is the integer part, and 0.2 is the fractional part. Makes sense? So whenever I ask you the greatest integer of any real number which is not an integer itself, in your mind you should do this. You should write it as integer part plus fractional part. And what is the integer part that is there inside? This one. So the greatest integer of 1.2 is 1. That is the meaning of that. So using the same logic, you people tell me what is the greatest integer of 3.4. Even without doing, you can tell me.
3.
That's the answer. Okay. So that is with respect to the positive values. Now the next question is, if I have the question of what is the greatest integer of minus 2.3. This is where the challenge starts. Let's say I'm interested to find what is the greatest integer of minus 2.3. So I can write minus 2.3 as minus 3 plus 0.7 or minus 2 minus 0.3. If I write it like this, see, but for positive values, we are fortunate. You cannot write it in two combinations. But negative can be written as integer plus fractional, integer minus fractional. So if I take the first one into consideration, what would be my answer that I'm going to report?
Minus 3.
Minus 3. Had I taken the second thing into consideration, I would have reported
Minus 2.
So how can same value come out? Because function, the same input cannot have two different outputs, no, according to function. It will become a relation. But the name itself is suggesting it should be a greatest integer function. Then how do I avoid this confusion?
Oh, minus 2 is greater.
You don't take it like that. How you do is, here I told you one thing, no. I told integer part and the fractional part, no. The fractional part should always be written as a positive value. So in both the cases, where is the fractional part taking the positive value?
Minus 3 plus 0.7.
So I should take this into consideration. This is wrong. So whenever you are asked to calculate the greatest integer of a number, you write it as integral part plus. I stress on that. It should always be plus the fractional part. Fractional part should always be positive. It should not be negative. So the answer is minus 3, not minus 2. So having said this, what would be the greatest integer of minus 4.5? Even without doing, you can tell me. The number on the left of it. Switch on your
5.
mic and
Minus 5.
that's the answer. So having said this, if I try to represent this on a number line, you know how a real number line is represented, right? If this is going to be 0, if this is 1, 2, if I want to write the greatest integer of 1 point something, then the greatest integer will always be the integer on the left of it. If I want to write the greatest integer of something like this one, minus 1, minus 2, minus 1 point something, then the greatest integer is always on the left of it. You need not sit and do all these things, writing it as fractional value and all those. You need not break your head like that. I gave that example only for you to understand. Are you able to understand? So whenever you're writing the greatest integer, it is always on the left-hand side of the decimal value.
Understood, sir.
Clear? So that is how the definition is given. So read the statement, greatest integer that is less than or equal to the number itself. When will it be less than? When it is a decimal value. When will it be equal to? When it is a integer value. For example, greatest integer of 1 is 1 only. That is where it is equal to. Whereas greatest integer of 1.2 is 1, which is less than 1 point. That is the meaning of that statement. Am I clear with this? Now I told you some books refer to it as step of x. No, the reason for that being the graph. Now you tell me, what is the greatest integer of 0? 0 itself. What is the greatest integer of 0.1? I told you already, you need not break your head. 0 point anything, the value is left side integer, 0. 0.2, 0. Till 0.999999, it is going to be 0. So from 0 till that value, it will be a 0. I'll put an open circle like this. Whenever I put an open circle like that, meaning is it's a point of discontinuity, meaning the graph starts breaking at that point. The graph will jump from that point. When I say jump, it can jump in any direction, need not be above always. It can jump above, below, right side, left side, wherever it wants, it can jump. Are you able to understand?
Yes, sir.
Yes. So, again, what is the greatest integer of 1? It is 1 itself. So, the greatest integer will continue to be 1 till which value? Till 1.999999, how many ever nines you have. Exactly at 2, what will happen? The graph will jump to 2 because the greatest integer of 2 is 2. So that is why exactly above 2, we have an open circle. Exactly above 2, we have an open circle. After that, it will become 2 till the 3. And from 3, it will become 4. So if you observe, is it not looking the form of a step? So is the graph not looking like stepwise increment? That's why it's called a step of x. But we saw only for positive values. So anything for, if it is minus 0 point something, what will happen? So greatest integer of minus 0 point something is?
0.
No. Minus 1. Look at this graph, no. It's minus 1. So what will happen to the graph? It will be like this and a circle. It will be like this and a circle. It will be like this and a circle. So where will that open circle come? At all the consecutive integers, there will be an open circle. Because that is where the graph is getting broken. Am I clear with this?
Yeah, sir.
Yes. See, this point I stress so much because you will see, you will have a lot of applications next year on this function. At that time, don't forget it. I'm not sure if you'll remember it for 1 year, but yeah, don't have the logic in your mind. And the last theoretical concept with respect to this chapter itself is algebra of real functions. So when I say algebra of real functions, right, you can either perform addition, subtraction, multiplication, or division between those two functions. Okay. So whenever you do something like this, you get the answer in this way. So when I talk about addition of two real numbers, we get f is a function mapped from some domain x to the codomain R. And g is a function mapped from x to R, b to any real functions, where x is a subset of R. When will it be a real function? When the domain of the function is a subset of the real number. Then f plus g will also be a function. Listen to this carefully. F plus g will also be a function which is defined from the same domain to the same codomain, given by f plus g of x, or you can write it as f of x plus g of x. Basically, what you're doing is you're adding. Similarly, if I talk about subtraction of real function from another, then f is a function mapped from x to R. G is also a function mapped from x to R, be to any real function where x is a subset of R. Then f minus g will also be a function mapped from x to R, given by f minus g of x is equal to f of x minus g of x. Basically, you're subtracting one from the other. Okay. And the third is multiplication by a scalar, meaning scalar is a number. So you can have a function. So here, don't get confused. It is not multiplication of a function with a function. Rather, it is multiplication by a scalar, in the sense, I already gave you a function. You need to multiply that function with some scalar alpha, with some number alpha. That number can be plus 2, minus half, plus half, whatever it is. So let f be a real function mapped from x to R and alpha be a scalar. Then the product alpha into f is a function from x to R, which is defined as alpha into f of x or alpha into f of x. So it is just a notation, both mean the same. Most of the times we use this one. We use alpha into f of x. Okay. The next is multiplication of two real functions. So here we are multiplying two functions itself, not the previous case. There the product was multiplication by a scalar. Okay. So multiplication of two real functions means if f is a function map from x to r, g is a function map from x to r, then f into g will be a function map from x to r, which is given as f into g of x is equal to f of x into g of x. Okay. So this is also called as pointwise multiplication. And lastly, what you can do is you can take the quotient of two real functions, or you also call it as division of two real functions. So let f and g be two real functions defined from the domain x to codomain R, where x is a subset of the real number. Then the quotient of f by g is denoted by f by g, which will be a new function, which is defined by f by g of x is equal to f of x divided by g of x. But an important condition here is you should always ensure that g of x is never equal to 0. Meaning the domain should not consider that value of x which will generate g of x to be 0. Okay. So make a note of this. It's there in your textbook actually. It's there in your textbook. You can make a note there itself so that we can save time. We'll try to concentrate more on problems. So let me know once you're done. Done?
Yes, sir.
Shall we solve problems?
Yes, sir.
Yes, sir.
So listen to this. Now you're going to answer one by one. Let's go in the order. So example number 16. Let f be a function where f of x is equal to x square. 1 minute. So where f of x is equal to x square and g of x is equal to 2x plus 1. Both are real functions. Find f plus g of x. So f plus g of x is f of x plus g of x. Balaji, tell me.
So f of g. So the answer is x square plus 2x plus 1.
That's it. So next is f of x minus g of x.
The answer is x square minus 2x minus 1.
Chitesh, you tell me f of x into g of x. I'm not able to hear.
Sir, can you hear me now?
Yes, sir.
F of x into g of x is
X square. Just multiply them.
x square of 2x plus 1.
That's it. So 2x cube plus x square. What is f of x by g of x?
X square by 2x plus 1.
Okay, this is where we need to be careful. X square by 2x plus 1, where 2x plus 1 should not be equal to 0. Meaning x should not be equal to minus r.
Minus 1.
So you need to mention this. For other things, we don't have a problem because we don't have a denominator. Am I clear with this?
Yes.
I didn't understand the second question. Can you explain?
Which second part? Huh?
Yeah.
Which one? This one.
No, sir, after that. The last second step.
This one. See, f of x by g of x is x squared by 2x plus 1. No. What did we say in the case of f of x by g of x? G of x should not be equal to 0. So what is g of x in this case? It is 2x plus 1. 2x plus 1 is not equal to 0 means x is not equal to minus half. Ananya, are you clear?
Yes, sir.
Yeah. So it's very simple. Whenever you divide one function with another function, you should always equate the denominator to a non-zero value. That's it. See. Clear with this? X is not equal to minus half. Right. Let's do the 17th one. F of x is equal to root x, g of x is equal to x, be two functions defined over the set of non-negative real numbers, f plus g of x. So f of x plus g of x. It is
Root x plus x.
f of x minus g of x.
Root x minus x.
Ananya, you tell me what is f of x into g of x? This root x is f of x.
Root x plus
Not plus, it is into. F of x into g of
x.
root of, so basically it is x root x, or you can write it as x power 3 by 2, everything means the same. How did I write x power 3 by 2? Because x into x power half. X power 3 by 2. And yeah, you tell me for this, my f of x divided by g of x.
Root
It
x
is,
divided by x.
but what is the additional point you should write?
1.
Denominator should not be equal to 0. What is the denominator there?
X is not equal to 0.
That's it. Understood?
Yes, sir.
This is how you need to mention. Okay. So we will start solving the problems. So first one, which of the following relations are functions? Give reasons if it is a function. Okay, give reasons. That is the first part. If it is a function, determine its domain and range. So first one, is it a function? So whenever you see an ordered pair, what is the checkpoint you need to have? No two ordered pairs should have the same.
It
No
is
two ordered,
functions, sir.
no two ordered pairs should have the same.
The
My
second
starting first.
They should not have the same starting number. That is this. The first number should not be the same in both the ordered pairs. The first one.
It is a function.
function, sir.
Yes, it is a function. It is a function. What about second one?
It is also a function.
Yes. What about the third one?
It is not a function.
Not a function because 1, 3 and 1, 5 have the same starting numbers. Yes. So this is something I wanted to explain. Listen. Here, the question is find the domain and range of the functions. So f of x is equal to minus x. I'll do one thing. I'll explain this alone at the end because I'll give you an algorithm to solve. Remind me, okay? So the third one. A function f defined by f of x is equal to x minus y. Write down the values. F of 0.
Minus pi.
F of 0 is minus 5. F of 7, 9. F of minus 3 is minus 11.
Minus 9.
So the function T, which maps temperature in degree Celsius into temperature in degree Fahrenheit, is given by T of C is equal to 9C by 5 plus 32. So what is T of 0? Means the question is 0 degree Celsius is how much value in terms of degree Fahrenheit? That's what the question is. So T of 0 is equal to 5. Wherever C is there, I'm going to substitute a 0. Because the variable is C. So it is going to be 32. Means 0 degree Celsius, the meaning of this is 0 degree Celsius is equal to 32 degree Fahrenheit. Okay. Similarly, what is T of 28? So 9 into 28 divided by 5 plus 32. I'm leaving that to you. Similarly, what is T of minus 10? 9 into minus 10 divided by 5 plus 32. This will cancel this 2 times. So minus 18 plus 32, it comes out to be 14. So minus 10 degrees Celsius is equal to 14 degree Fahrenheit. Is that point clear? The value of C. So last point is, the last question is, C is equal to how much when T of C is equal to 2 and 2? Means this time they have given in terms of Fahrenheit. We need to do the reverse. So 2 and 2 is equal to 9C by 5 plus 32, which implies 9C by 5 is equal to 2 and 2 minus 32 is 180. This will cancel this 20 times. So C will be 100 degrees Celsius. So basically, this is called as the function value. In mathematics, we call this as the function value. Am I clear with this? Right? It's a simple problem.
Yes, sir.
Excuse me, sir. Already gave this exercise as homework.
Which one? Where did they give x is equal to?
No, this exercise you gave it as homework for last week.
Yeah, I gave it, but did you all complete it?
Yes.
Finished? Okay. So you can verify the answers. Now, fifth one. Find the range of each of the following functions. So for range also, I'll give you a method. It's only 5 problems, no? Now I need to explain you how to find the domain and range of functions. So if you observe, right, what is domain basically? Domain is basically set of input values for which output is not equal to infinity. This is one way of defining, or I can say for which the output is a finite number. Set of input values for which the output is a finite number is also called as the domain. Clear with this? So when I take f of x is equal to negative of mod x, what is a domain here? Means you always look at that function. There are only 2 kinds of, I would say rather, 3 kinds of functions which you will get. One type of function is you will have only numerator. If at all you have only numerator but you don't have a square root, mostly what will happen is the domain will be real numbers. You can substitute any real number. So in the place of minus of mod x, if I substitute any real number, I will still get an output. Am I right? I'll get a finite output. Is that right? Because in real numbers, what is not included? Minus infinity and plus infinity is not included. They're in the open bracket. Am I clear with this, guys? But how
Yes,
to
sir.
find the range? So what is range? It is set of all output values. So forget the minus sign, okay? If it was only modulus of x, according to the definition, if I substitute any real number, what will the output be? It will be a positive number. So positive real number. Am I right? It will be a positive real number. But for f of x is equal to negative of mod x, what will happen is, I have a positive number here and I have a negative number here. What will happen to it? It will become negative. So what is the meaning of this? Range of negative of mod x is going to be all negative real numbers. You can get 0 also. So you will get minus infinity to 0 where 0 is included. Are you able to understand?
Yes, sir.
See, this is one way. We already saw the graph. Now, what graph is this? There's a graph for
Modulus function.
modulus of x. No. So, if at all you multiply any function, if you multiply the whole function with a minus sign, it will always get converted symmetric with respect to the x-axis. So, this is the graph for minus of mod x. See, it's very simple. Okay. This is the graph for y is equal to x square. If I ask you to draw the graph for y is equal to minus x square, what will happen? Just draw it like this. Because the whole function x square is completely multiplied with a minus sign. So it will get inverted with respect to the x-axis in the downward direction. Am I clear with what I'm explaining? Are you able to understand?
Yes, sir.
So if you observe, why I'm telling you in terms of graphical method is the graph will help us to find the range faster. So if you observe the graph, no, what is the range of y is equal to x square? The range of y is equal to x square is 0 to infinity. How did I tell that? Because the least value I'm able to see on the graph sheet is 0. The least value I'm able to see is 0. And where is the graph going to? It is going till plus infinity. Whereas, what is the least value I'm able to see for minus x square? 0. And the value is going to minus infinity. So always the value in the negative, in the downward direction is the least value. When you report it, no, you should write it as minus infinity to 0. You should always come from bottom to top. When you're writing the range, come from bottom to top. When you're writing the domain, come from left to right. That's the logic. Are you able to get some perspective? How to
Yes,
think?
sir.
Yes. Okay. This is another important question. So f of x is equal to root of 9 minus x square. So whenever you are asked to calculate the domain of functions with square root, so when you're asked to calculate the domain of functions with square root, there are two things you need to check. If the square root is in numerator, then you write the value inside the square root, then you write the value inside the square root to be greater than or equal to 0. Why did I write it like this? Because inside a square, you can find the square root only for positive numbers, or at the max, you can find it for 0. Whereas if the square root is in denominator, then write 9 minus x square is strictly greater than 0. Meaning, had the question been root of 9 minus x square, you will use this logic. Had the question been 1 by root of 9 minus x square, you will use this logic. Reason being, whenever denominator comes, the denominator should not be a 0. Had I written it as greater than or equal to 0 in the second case, my denominator would have been a 0. So I should not write equal to 0. Are you able to understand? It's a very thin line. It's a very, very thin line, but you need to be careful. So 9 minus x square is greater than or equal to 0 since it's in the numerator. Am I clear with this?
Yes, sir.
Yes. So this is, so right side, whatever I've written is for your idea, for your understanding. You need not write that in the exam. All that you need to know is for f of x to be defined, 9 minus x square should be greater than or equal to 0. Now I know why it is greater than or equal to 0, because it's in the numerator. Okay. Then if I take the minus sign out, it will become x square minus 9 is greater than or equal to 0. Is this point clear? Okay. So whenever you have inequality, listen to this carefully. Unfortunately, I can't teach you completely in depth because we'll be learning about this in 6th chapter. So whenever for the inequality thing, you take the minus sign to the other side, the inequality will change. Meaning, I took the minus sign out. No. Whenever I'm solving a quadratic equation, right, I always see that x square has a positive sign. That is the reason I took the minus sign out. Okay. So when I take the minus sign out, it becomes x square minus 9, because I'm taking the minus to the other side, inequality changes, means it becomes less than or equal to 0. Am I clear with this? X square minus 9 is less than or equal to 0. Then you will have x minus 3 into x plus 3 is less than or equal to 0. Okay. Now, after you come to this step, all that you need to do is draw the number line, take 0 here, or 1 minute, no need of 0 also. Look at the checkpoints where the function will become 0. So x minus 3 into x plus 3 is there, no. So the critical values, the endpoints are minus 3 and plus 3. Why? If I equate x minus 3 equal to 0, I get x is equal to 3. That is this point. If I put x plus 3 is equal to 0, I get x is equal to minus 3. That is this point. So all that you need to do is check for what happens when you substitute a number less than minus 3. So when you substitute a number less than minus 3 in this inequality, this is called as inequality, not an equation. This is called inequality. If you substitute a number less than minus 3, for example, if you substitute minus 4, what will happen here is this will be negative and this will also be negative. Am I right? Makes sense. So you get a positive value. So whenever you get a positive value, put it on top of the number line. When you substitute a number between minus 3 to 3, for convenience, I'll choose 0. When you substitute 0, you get negative value, you get positive value. So negative into positive is negative. So if it is negative, I'll put it below the number line. When you substitute a number greater than 3, you again get positive into positive. You get a positive value. So if you look out throughout the number line, what values of x am I supposed to choose for this inequality to be true? I need to choose only those numbers where the product of x minus 3 and x plus 3 is coming out to be less than 0. So where am I getting less than 0? Between minus 3 to 3. Am I clear with what I'm explaining? So the domain is x belongs to minus 3 to plus 3. Am I clear with every step that I explained? Is there any doubt? If there is any doubt, get it clarified. See, since you're seeing it for the first time, I explained this much. With practice, you can directly write it. You need not write even these steps. With practice, you'll be able to directly tell me the answer as -3 to +3. Are you clear with all the steps? I need a confirmation.
Yes, sir.
Yes, sir.
Yes. Write it down. So this is the domain. So what about the range? Range is the values of y that you're going to substitute. So you look at the domain, no, you're going to substitute a value between -3 to 3. So when you substitute a value between -3 to 3, what is the least value you're going to get? When you put -3 or +3, what is the least value you're going to get? The least value you're going to get is 0. Okay. For range, I'm going to explain you. Listen to this. I have to explain this to you. See, for range, what you need to do is put f of x is equal to y. So y is equal to root of 9 minus x square. So that is the first step. This is the first step. Second step is write x in terms of y. Means square on both the sides. You get y square is equal to 9 minus x square. Right? Which implies x square is equal to 9 minus y square. Which implies x is equal to plus or minus square root of 9 minus y square. Is it clear till this step?
Yes, sir.
Yes, sir.
And third step is, see, basically what happened is x became equal to g of y. So what was the function they gave you? They gave you the function y is equal to f of x. Because left side you had y, right hand side you had the function of x. You just swapped it. Now what you did is left hand side you brought the x by doing all the mathematical manipulations, and right hand side became a function of y. Are you able to understand that point? So find values of y for which x is defined. Find values of y for which x is defined. So what is the meaning of that statement is, I need to find the domain of this function. So to find the domain of a square root, what did I tell you? If the square root is in the numerator, write the value inside the numerator to be greater than or equal to 0. So what should I write? 9 minus y square, I should write it as greater than or equal to 0. Then what should I do? Minus of y square minus 9 is greater than or equal to 0. Y square minus 9 is less than or equal to 0. When you solve this, right, you will get y belongs to -3 to +3 only. I'm not sure with your face expressions, I'm not sure if you're able to understand that. Am I clear or not?
Yes, sir. Sir, one thing, sir. So essentially what we are getting is the same thing as the domain.
In this question you are getting. Not necessary for every question you will get this.
Okay, sir.
Unfortunately, in this question, it is happening like that. But there is a problem here. Check the answer. Answer would have been 0 to 3. Check your textbook. Its answer 0 to 3. Check your textbook at the book back.
Sir, it's in 0, 3.
That's what I told you. It will be 0 to 3. I'll tell you what, I made a small mistake here. Thing is, I wrote y is equal to root of 9 minus x square. No. So, see, I wrote y is equal to root of 9 minus x square. No. Square root will always give me a positive value. So, I actually missed to write this. Y is greater than or equal to 0. Did you understand? So, because y is the output set. So, y is greater than or equal to 0 is what I should have written. And y belongs to minus 3 to 3 is also correct. So, what I should do is, I need to take the intersection of y belongs to minus 3 to 3. So, the meaning of this is, if I draw a line like this is 0. Y greater than or equal to 0 is this region. Y belongs to minus 3 to 3 is this region. Among this, which region is common? So what is this number? 0. What is this number? 3. So that is why it is 0 to 3. Am I clear with what I'm explaining? Right? So you make a note of this. I'll give you another problem which you have to solve. So make a note of this.
Done, sir.
Exactly 5 minutes time. Okay, I want the answer for the first one.
Excuse me, sir. Excuse me, sir.
Yeah, tell me.
So, is the domain for the first one 3 comma minus 3?
Uh-huh. I'll tell you. Till last step you would have done it correct. I'll tell you what is a mistake you would have done. X square minus 9 is greater than or equal to 0.
Yes.
X minus 3 into x plus 3 is greater than or equal to 0.
Yes.
Right. So you would have drawn the number line minus 3, 3.
Yeah.
If you substitute any number less than minus 3, you will get plus. If you substitute any number between minus 3 to 3, you get a minus.
Yeah.
If you substitute a number greater than 3, you get a plus.
Yes.
So what is it telling me? that x minus 3 into x plus 3, I need to choose only those values of x where I get positive output. So where do I get the positive output? From minus infinity, I get the positive in where x belongs to minus infinity to minus 3. 3 is included, minus 3 is included. Union 3 to infinity. How did I say minus 3 is included? Because I use greater than or equal to. So did you understand this answer for domain?
Okay, sir.
Sir, is the range between 3 and minus 3?
Range?
Between 3 and minus 3?
Uh-huh. For range, what you do is same logic. Y is equal to root of x square minus 9. But one thing you need to remember, what is it? Y is greater than or equal to 0. Did you write this? Okay, y is greater than or equal to 0. Why did I write y is greater than or equal to 0? Because here there is only numerator, that is why equal to. Okay. Now the next thing I'll do is I'll square on both the sides. Y square is equal to x square minus 9, which implies x square is equal to y square plus 9. Am I right? So if you observe, I need to find the values of y for which x is defined. So square root of y square plus 9 means y square plus 9 should be a positive value or equal to 0. If you observe, y square is always a positive number. 9 is a positive number. Sum of two positive numbers will always be positive.
Positive.
So in this case, I can write y belongs to R. Because y square plus 9 is always greater than or equal to 0. Whether you substitute negative real number or positive real number, it will be always greater than or equal to 0. But here, how many conditions did I impose? 2. What are they? One is y should be greater than or equal to 0. And the second is y belongs to R. So when I draw the line like this is 0. Y is greater than or equal to 0 is this thing.
So is it 0 to infinity?
Yes. Y is greater than or equal to 0. Minus infinity to infinity is this thing. So what is the common region?
0 to infinity.
That is the answer. So y belongs to 0 to infinity. Am I clear with this? See, these are all slightly beyond your textbook problems only, but it is important for you to learn. Okay.
So 1 minute, sir. Can you go above for the domain part? Yeah. Thanks.
1 minute, wait. It will be easy to copy now. Clear with this? Shall I proceed?
Yes, sir.
So the next question is, f of x is equal to 1 by root of x square minus 4. So here, how should I start with for the domain?
Root of x square minus 4 is strictly greater.
Not root of. It's not
Okay,
root
x
of.
square minus 4 is
Ah.
strictly greater than.
X square minus 4 is strictly greater than 0. So what I'll get is, I'll get x minus 2 into x plus 2 is greater than 0. So after you get the inequality, all that you have to do is first draw the number line, take the endpoints. What are the endpoints?
Minus 2 and 2.
That's right. So if you substitute a value less than minus 2, let's say minus 3, you think and tell me what are you going to get?
If we substitute a number less than minus 2, we get a positive number.
Correct? If you substitute a number between minus 2 to 2,
We get a
Take
negative number.
you get a negative number. You substitute a number greater than 2,
Positive number.
positive number. So what is that I need? I need positive values. So I need those values of x for which the product is positive. So what should be the domain? X belongs to
0 to infinity. 0 comma infinity.
Where is the positive value? Number line, where is the positive value?
Okay, 2 comma infinity.
2 comma infinity irukku. Where else do you have?
Minus 2 comma infinity.
You're missing the left hand side. Left hand side also you have positive. No.
Okay, minus
Minus-
infinity comma minus 2 union 2.
1 minute. So don't read it as minus infinity comma minus 2. Say it as minus infinity to minus 2.
Okay.
Okay, minus infinity to minus 2. But a point to be mentioned here is minus 2 is not included. Why should I not include? Because look at the inequality. It is not greater than or equal to. It is strictly greater than. So minus 2 is not included. Union means and. And where else do you have positive?
2 to infinity.
So this is the domain. Did you understand?
Yeah, sir.
Yes. So that is one thing. Let me complete the other part also. For range, what am I supposed to do? I'll take y is equal to 1 by root of x square minus 4. By default, wherever you have a square root based problem, y will be greater than or equal to 0. So here, if you observe, I wrote y greater than or equal to 0 because, 1 minute. Here you cannot get equal to 0. Here y is positive. Y cannot be equal to 0 because if it has to, wait. There is a possibility.
No, sir, but in the numerator we have 1, right?
It's not about 1. See, y has to be equal to 0, then the denominator has to be infinite. It is possible. So y is greater than or equal to 0. Okay. And now cross multiply. Root of x square minus 4 is equal to 1 divided by y. So x square minus 4 is equal to 1 by y square. Am I clear with this?
Yes.
Squaring on both the sides. So x square will be equal to 1 by y square plus 4. So what will happen to this? This will be root of 4 plus y square divided by y square. sorry, y square plus 4 divided by y square. So what will x be equal to? Plus or minus square root of y square plus 4 divided by y. Is it clear till this step? Is it clear till this step?
Yes, sir.
Yes, sir.
Okay. So first, I wrote this y greater than or equal to 0. First thing to be kept in your mind. Second thing is, I need to, from this, I need to find the values of y for which x is defined. So when will x be defined? When the whole square root, see, square root is not there only for the numerator. Here it is there for the denominator also. The whole square root should be a positive value. Means y square by 4 by y should be a positive number. Actually, it can be, yeah, y square by y should be a positive number. Accepted? Is the point clear? So, when can a ratio be positive? A ratio can be positive when numerator is positive and denominator is positive, or numerator is negative and denominator is negative. They both should happen simultaneously. If numerator is positive, then denominator should also be positive. If numerator is negative, the denominator should also be negative. Am I clear with this point?
Yes, sir.
Okay. Now, if you see, y square by 4 is there. No, y square by 4 by default is always positive. Why? Why is it so? Because y square is a positive number. 4 is a positive number. Sum of two positive numbers is always positive. So what is the other condition that should get satisfied? The denominator should be positive. That's it. So this is 2. It's very simple, guys. The first step, you will define something with respect to y. After you write x in terms of y and then solve, you will get another condition on y. Take the intersection of both. So y is greater than or equal to 0, and from the second condition, y is greater than 0. So what is the intersection? That's it. Intersection is always lesser value. Union is always bigger value. They're able to actually understand the real application of intersection and union also. See, I repeated, these kind of problems you will not find it in textbook. Actually, they are simple only, but since you're seeing it for the first time, it might appear slightly complicated, but with practice, trust me, you do 15-20 problems, it will become very easy. In fact, you do this graph, no, like this number line, you need not even draw, you can directly tell the answer. You'll have that level of practice. Okay, all that we need to do is problems only. But I hope conceptually you could understand. You're able to get some perspective, no?
Yes, sir.
Okay. So based on this, what we have is, see, you have the miscellaneous problems, no? So these miscellaneous problems, you guys solve first. Okay. You have any doubt, you can reach out to me. Secondly, see, tomorrow I have some personal work due to which I'm not available. I'll not be able to handle class. So in tomorrow's class, what I want you guys to do is during the same time. I'm not giving it like a homework where you can substitute after 2 days or something. This time you're available, no? So from 11 o'clock to 1 o'clock, make sure you sit on this miscellaneous, complete, and upload your answer sheets in the app. I'll be checking it. So miscellaneous exercise to be completed from your end, and whatever doubts you have, mark and keep it. Okay. So miscellaneous is to be solved between 11 a.m. to 1 p.m. Solve it. 2 hours is more than sufficient. You can do it fast also because you have solutions also. But don't cheat. Don't look at the solutions. You try to do on your own. If you get stuck, mark it as a doubt and ask me. Okay. So you can use this student support number 63692108999, which is available and you can drop your doubts there. You need not wait till the next class. You can drop your doubts there. Any questions you have, you will get the response within 3 to 4 hours. If I'm in the class or something, I'll not be able to respond. Apart from that, I'll respond. So if the problem is tough or something, we'll solve it back and send it. Okay, make use of this and work on this. So am I clear with this? Right, because you know, right, you all got the message regarding the test on 29th.
Yes.
Like after, yeah, exactly after 2 weeks, you have both the chapters combined together. You'll be having a test. Okay, so I want you all to solve the study material completely. First, concentrate on that. Once you are done with it, you can let me know. I'll give you extra assignments if needed. We have questions in the app also where we have MCQs, which will give you instant results. So all that you need to do from your side is you need to practice first. Without that, I can't help you. I'm concentrating more of teaching you theory because if you understand the concept, math can be solved. Most of the issue is most of them learn math like a formula subject. Don't do that. If you're going to do like that, you're never going to understand. Okay. So whatever concepts I've taught you, apply them in the problems. You first solve and then come to me. Then I'll be able to help you faster. Is that clear? Yes. So I'll see you guys. Maybe see before your test, if you have doubts, no, depending on the number of questions you're sending me on the student support number, I will decide whether I need to conduct another class or something. So I'll do some previous year questions or whatever is needed at that point of time. I'll be able to know that based on your performance. Am I clear with this? Yes?
Yes,
okay. Tomorrow I'm expecting this. Don't miss it. We will track. Okay. So that's it from my side. You can wind up this.
Thank you, sir.
Thank you, sir.